Help us out here. I'm starting to record this class for us. Now, our goal today is that we're going to be able to answer these 6 questions. Write a balanced equation about the synthesis of ammonia. State the meaning of the equation in terms of numbers of molecules and moles. Give the mole ratio between nitrogen and hydrogen, and then we're going to use that mole ratio to answer a bunch of questions. I will let you know, when it comes to stoichiometry, there's really little to no new material in this unit. What we are doing in this unit is we're using all these different tools that we've picked up to this point. Everything up from unit 1 to unit 7 was theoretical. Now we're putting it all together. Now we're getting into the more practical side of things. I will say this. I also forgot to mention this as well. The tests, Unit 7 tests are graded. Everything's put into your grade book. Everyone should know what they got if they were here. I will say this. One thing I did see, Unit 7 was a bit of a lighter unit. We saw with several students, huge grade rises that were effectively getting around a 30%, or maybe even a little bit below that. We're getting around 60, 65, even all the way up to 75. Huge leaps and bounds. Look, if you're doubling your points from one test to another, that's a big change. That's nothing to scoff about. That is some good work there. But the main thing here, so we're going to that I'm leaning into, is that we did it better this go around than we have in previous classes. Positive. We should be rewarded for that one. Unit 8 is going to be very much like Unit 7. Not a lot of new material, but we're going to change how we view things. So the first thing I want you guys to do, and you're more than willing to work with a neighbor. Now, everyone, I think in the background I don't have periodic tables for you. I'm going to get some periodic tables for you. If you look at your paper, 4A, it asks me to write a balanced equation for the synthesis of ammonia from my 2 elements, nitrogen gas and hydrogen gas. I want you to work with a neighbor. I'm going to give you 3 minutes to do it, to write a balanced equation. We are going to use that one balanced equation for everything that we're going to be doing on that sheet of paper in front of you. So I'm going to find a quick timer. You're going to go ahead and balance that equation, and after 3 minutes, we're going to check it together. There we go. I will remind you guys, one or two of your elements are diatomic. What I mean by diatomic, we don't just find one by itself. We usually find it with others of the same type. All right, guys. So let's look at the board together. Stop that. Okay. All right. Oh, man. Pull you down right here. You see. All right. So I know ammonia is my answer. It's my product. I know that there's some hydrogen that's involved, and I know there's some nitrogen involved. Question to you. Nitrogen and hydrogen. Are either one of them diatomic? Yeah. Who's diatomic? Both of them are. How I know this is I look at my periodic table over here on the side of the wall here. I see hydrogen is an orange box. I see nitrogen is an orange box. I look at my key at the bottom, diatomic elements, meaning that I never find them by themselves. Sir.
So if you didn't have access to the periodic table, how would you
memorize? Okay. So I got to balance my equation, right? I got nitrogen, hydrogen. Now I see I have two nitrogens on my reactant side. How many hydrogens do I have on my product side? I currently have one. How do I fix that? I'll put a coefficient in front of my ammonia. 2 times 1 nitrogen, now it gives me 2 nitrogen. I changed my ammonia, so I'm going to go over here. 2 times 3 hydrogens gives me 6 hydrogens. Over my reactant side, I have 2. How do I fix that? What am I going to do? How can I get 6 on both sides? What do you think, Josh? I'll put coefficient 3. 3 times 2 hydrogen now becomes 6 hydrogen. And my equation is balanced. Key thing is that we're trying to in order for us to do stoichiometry, we must first balance the equation. If we do not balance the equation, we will never get the right answer. Always has to be there. So I want to move on to question B. So I need to state the meaning of the equation in terms of molecules and moles. Now, just so we have it, I'm going to rewrite my equation because we're going to keep using this for the rest of the class period. I need to say what that means. In terms of molecules and moles. If I have one molecule of nitrogen gas, and it reacts with how many molecules of hydrogen? You have the equation above here. One molecule of nitrogen gas is going to react with how many molecules of hydrogen? Not 6. There's 6 atoms. How many? Yeah. There's 3 molecules, right? Remember, my molecules are my compounds, right? H2, it's not just a single atom, it's a molecule. So 1 molecule of nitrogen gas reacts with 3 molecules of hydrogen gas to produce how many molecules of ammonia? Hmm? 2. Where did I get the 2 from? The coefficients. We are going to be using these coefficients with a lot of our statements. 1 molecule of nitrogen gas interacts with 3 molecules of hydrogen gas to produce or yield 2 molecules of ammonia. So that's us answering in molecules. What about moles? 1 mole nitrogen gas reacts with how many moles of hydrogen gas? Hmm? 3 moles. Where did I get the 3? By coefficient. To produce how many moles of ammonia? One mole of nitrogen gas reacts with 3 moles of hydrogen gas to produce how many moles of ammonia? 2. Where'd you get the 2 from? The coefficient. I am writing out the ratio. I need, in order for this reaction to work, I need either 1 molecule of nitrogen gas to interact with 3 molecules of hydrogen gas to create 2 molecules of ammonia. Or, another way of saying that, I need 1 mole of nitrogen gas to interact with 3 moles of hydrogen gas to produce 2 moles of ammonia. Everything that we are going to do is going to relate to putting things into moles and then putting it into our desired equation. We are going to see that this unit is very much a plug and chug type of unit. And in a little bit, I'm also going to present to you guys, this mole map. And I recommend, if there's anything that you ever write on your test for Unit 8, because I always tell you, if there's something rattling around in your head, a great testing strategy, as soon as you get that test, that scrap piece of paper, is to write that thing down so you can just go back and reference it. The mole map, what you're going to get in a couple minutes from now, is one of the best things you could do for yourself when you walk into Unit 8 test. Number C. I'm going to rewrite my equation because, like I said, I'm going to keep using it. I need to figure out what the mole ratio is between my nitrogen and my hydrogen. Based off my equation below it, how many moles of nitrogen do I have in front of me? 1, right? I have 1 mole of nitrogen. Give me one quick second. And absolutely. How many moles of hydrogen do I have? 3. I'm pulling those coefficients to tell me what my mole ratio is. For every 1 mole of nitrogen gas for this reaction to work, I need 3 moles of hydrogen gas. Keely, go ahead. Let's grab my pass and make sure. I think my notebook's. Is it open? Yeah, my notebook's open. Okay. So now I want us to work together to answer this question. Question D in our warm-up. Calculate the number of moles of hydrogen required to synthesize 6.5 moles of ammonia. One thing that we're going to do with stoichiometry is that we're going to get into what we should be able to yield and what we actually yield. Theoretical yields, actual yields. And I can present you with, hey, I have X amount of reactants. How many products do I expect to get? Or I have X amount of products, which I see here. How much do I need for the reaction to work? So our first thing that we always want to make sure is that we have our balance equation. Now, we've already done this. N2, bless you, plus 3H2 yields 2NH3. Second thing I want to identify, what do I have? What's my given amount in my question? What do I have from my question? What value do I have in my question? What's the number? How many moles of ammonia do I have for my question? Really? Calculate the number of moles of hydrogen required to synthesize 6.5 moles of ammonia. How many moles are in my question? 6.5 of what? 6.5 moles of ammonia. So now I'm identifying what I have in my question. From my question, I have 6.5 moles ammonia. What am I trying to figure out? Moles of hydrogen. A key thing that's going to help you out and to help keep things straight in your question is writing out what's been given to you, what you want to find. So, if I need to figure out how many moles of hydrogen are used, I'm going to use my coefficients to give me a mole ratio. So I see from my balanced equation, for every 2 moles of ammonia formed, how many hydrogen molecules do I need? For every 2 moles of nitrogen formed, how many moles of hydrogen do I need? You pull it from your balanced equation. If I have 2 moles of ammonia, how many moles of hydrogen do I need? 3. This is my mole ratio. I'm going to multiply my given amounts by my mole ratio. And I'm going to do that using an equality fraction. So I'm using these two values. If I have 6.5 moles ammonia, I'm starting off with that, what should be my denominator? Ammonia or hydrogen? Ammonia. If I want moles hydrogen, what needs to be in my numerator? Hydrogen. So with a calculator, give me your value that you got from this. Is that my final answer, though? No. I start off with 2 sig figs. My final question has to end, my final answer has to end with 2 sig figs. 1, 2. So what's my final answer going to be? .8 moles hydrogen. Did we use anything new to answer that question? We talked about ratios before. We talked about moles in Unit 6. We used dimensional analysis all the way back in Unit 1. Last unit, we spent balancing our equations. Because you know how to balance equations, or at least you were tested on it, moving forward, I will give you equations that are sometimes balanced and sometimes not. You are going to have to be able to balance those equations. It's not a question of if, it's a question of when you will have to balance those equations. I'm able to pull the mole ratio directly from my balanced equation. All I'm doing is I'm multiplying what I have by that mole ratio. That's the biggest thing here. And the best part about this is that after I figure out what the mole ratio is, it says plug and chug. Easy peasy. In a second, I'm going to have you guys answer one by yourself. But first, I want to go over the steps that you're going to need to answer your questions. Now, on your notes, you're going to want to record these 5 steps. These are the 5 steps that are going to walk us through how to balance our equations. On your stoichiometry day 1 sheet, don't put it at the bottom of the sheet where it says to draw the mole map. We're about to do that in a second. On the back, towards the bottom of F, I want you to write down these 5 steps. First thing we got to do is we have to balance the equation. Second thing, to help us visually see where we're going with this question, we're going to always write the given amount, and then we're going to write down the desired unit. In the previous question, we were given 6.5 moles of ammonia. We had to figure out how many moles of hydrogen I need for that reaction to happen. Now, luckily for us, the items are already put into moles. We didn't have to convert from something into moles. Number 4, use the mole ratio, the coefficients from the balanced equation, to multiply, to multiply our given number. And lastly, when we have the desired moles, we are going to convert them into the desired unit. Yellow. John who? No, I only have one, but it sounded like it was a different last name. I don't have a John. John, is your middle name Angel? Oh, I'm dumb. I'm getting my Johns mixed up in my head. No problem. Bye now. John, you got early dismissal, my friend. Pack it up, you're heading on down. Whew, that looked bad on my part. But now I want to move into this mole map. Now, ladies and gentlemen, this mole map is going to make or break your experience with this unit. We're going to split our mole map into two sections. We have our given substance and our desired or wanted substance. How I'm going to jump from one side to the other of this table is through the mole ratio. None of this works without having everything in moles. So, John, you're going to do so I'm recording this class. I'm going to post this later today. The first stoichiometry worksheet, the one you picked up, that's your homework. Use that to the front. There's 7 questions. If you don't, I have harder questions on the back that you'll do for makeup. Okay? Okay. So in order to get to my mole ratio, I got to get my given substance to a mole. And in turn, it's going to give me my answer in mole. Now we're going to see my given substance written in 3 different ways. At times, it'll be written in mass. What's the symbol for mass? What do we use when we say I have the mass of something? What was the unit that we used? Grams. Now, in order to convert grams to moles, remember, it's 1 mole over the molar mass of an element or compound. If my given substance is written in mass, I have to convert it to moles. 1 mole is equal to the molar. 1 mole over the molar mass of an object. What if my given item is a volume? What unit did we use for volume? Liters. 1 mole of something was equal to how many liters? What was the equality that you use all the time for liters? 2.4 liters. What if you were given something in particles? These are atoms, or molecules. And the only time you're allowed to say F you to Mr. Wiseman without him writing you up with our formula units. 1 mole was equal to how many atoms, molecules, or formula units? 6.022 times 10 to the power 23, also known as Avogadro's number. In your stoichiometry question, you're going to have your given amount come in one of 4 options. You're going to be given the mass of something, the volume of something, the particles, or if they're merciful, they'll just give you the moles to make it a lot faster for you. It's one less conversion you have to do, right? But this is for my given. I take my given amount of material. I convert it into a mole. I'll then multiply it against the mole ratio to get the mole of my desired answer. If they are merciful, I only need to stop right here. But there are going to be times where I'm going to have to convert that mole into a desired unit. So if I was to convert it into mass, what would I expect to be in my numerator? If I have something in moles and I want to turn it to mass, what's going to be my numerator? Is it going to be moles or the molar mass? If I have moles and I want to convert it to mass, is my numerator what I'm going to keep? Moles or molar mass? What do we think, guys? What do I want to keep? Do I want to keep moles or molar mass if I'm going from moles to mass? I don't want moles. I want molar mass. I'm getting rid of the mole. So therefore, the mole's on my denominator. If I need to convert it to volumes, what am I going to put up top in my numerator? Moles or liters? I have moles. I want liters. So is my numerator going to be moles or liters? What do you think, Josh? Nope. That's all right. Remember, in my dimensional analysis questions, whatever I want to keep has to be in the numerator. Whatever I'm getting rid of has to be in the denominator. Lastly, if I was going to particles, these are my atoms, my molecules, or my formula units. What's going to be in my numerator? Moles or Avogadro's number? 6.022 times 10 to the 23 power. What am I going to have in my numerator if I'm going from moles to particles? Mole or 6.022 times 10 to the 23? What do you think? Yeah, I'll have that in my numerator. 6.022 times 10 to 23 over 1 mole. Oh, sorry. This is the pattern that I'm going to use. This is my mole map. Every question that we're going to take in Unit 8 is going to involve the use of this map. If there is ever something that you want to make sure you got rattling around in your head for this unit, this is what you want. So you want to have a chance to write this down? Let's see how well you can use it. So I'm on the back page now of my notes. How many moles of ammonia is formed from 7.8 times 10 to the 26 molecules of nitrogen gas reacting with excess hydrogen gas? Before we get too far, I want to talk about excess. When I have something in excess, do I have a lot of that or do I have a little bit of it? I have a lot, right? When it comes to our reactions, we don't need to worry about accounting for the hydrogen gas. So to help us out, it's important to know that we only have 7.8 times 10 to the 26 molecules of nitrogen gas, but we have a whole lot more hydrogen gas. So this number right here only goes to the nitrogen. It does not go to the hydrogen. So using our steps that we talked about last time, I had you write down. Balance equation. Write the problem like this. Convert everything to moles. Use the mole ratio. Convert to the desired unit. First thing we want to do, give you a quick second, is we need to write out that balance equation. Second thing, we need to rewrite our problem. What's my given substance in my question? What does my question tell me? What value do I get from the question, guys? Is it ammonia? Is it nitrogen? Or is it oxygen? I'll call you guys out individually. Yeah. Oh, no, sorry, not ammonia. I want to find out the moles of ammonia, right? What does the question give me? Nitrogen. How much nitrogen? So if I'm using step 2, rewrite the problem like this. The given amount is 7.8 times 10 to the power 26 nitrogen gas. What do we want to find out? We want to figure out how many moles of ammonia is formed. Step 3. I have to convert the given amount to moles. On your piece of paper, I want you to convert 7.8 times 10 to the 26 molecules of nitrogen gas to moles. And with that, I'm going to send Josh to the restroom real quick. I'm going to come around and see what you did. How do I convert 7.8 times 10 to the 26 molecules to moles? If I don't do that first, I cannot make this work. Whoa. How many molecules of nitrogen gas fits into 1 mole of nitrogen gas? What was the equality that you guys used? (6.022 times 10^23). That's my differential analysis question, right? 1 mole of any subject, of any item, contains 6.022 times 10^23 molecules, atoms, or formula units of that item. 7.8 second E, 26 times 1 mole divided by 6.022 second E, 23rd, gives us a pretty long number. So 7.8 times 10 to 26 power molecules will equal 1,295.25 moles of nitrogen gas. Step 4. Use the mole ratio, the coefficients from the balanced equation. How many moles of nitrogen did I use in my balanced equation? 1, 2, or 3? How many moles of ammonia did I use? My balanced equation, how many moles of ammonia did I use? Give me a second. In the balanced equation, how many moles did you use of ammonia? Gabby, how many moles of ammonia do you need? 1, 2, or 3? 2. Again, I use the coefficient in front of the ammonia, right? 2 moles. That's my mole ratio, 1 to 2. Give me a second. So I have to multiply my moles nitrogen gas by my ratio. 1295.25 mole N2. Am I going to use, what's going to be my denominator? What I'm getting rid of? Is it moles nitrogen gas or is it moles ammonia? What am I getting rid of? The nitrogen gas or the ammonia? What am I getting rid of? What do I want? Do I want nitrogen gas or do I want ammonia? I want ammonia. So that means I'm getting rid of the nitrogen gas, right? Right? So 1 mole nitrogen gas. What I'm keeping stays in my numerator. What am I keeping? Nitrogen gas or ammonia? Keeping the ammonia. So I have my unrounded answer. That's 7.8 times 10 to the 26 power molecules of nitrogen gas with reacting with an unlimited amount of hydrogen gas will yield 2,590.50 moles ammonia. Is this my final answer? No. How many sig figs can my final answer have? 2. 1, 2. What's my final answer going to be? Is it going to be 2.5 or 2.6? What do I have about these spaces right here? Where am I going to put here? Because if I owed you $2,590, I only gave you back $26, you'd be mighty upset with me. What am I going to put here? Zeros. Remember, I don't put zeros after the decimal because, remember, tailing zeros are not significant unless there's a decimal place there. The moment I put 0.00, I went from 2 sig figs to 6. If I wanted to get really clever with it, I could have wrote as 2.6 times 10 to the power of 3 moles ammonia. I'm going to have you do one by yourself. Because in a second, we only got 20-ish minutes left in class. You're going to do those 7 questions by yourself. So using the same reaction as we did before. How many grams of hydrogen react with 35 grams of nitrogen gas? I'll give you a hand with number 1. N2 plus 3H2 yields 2NH3. I'm going to give you 5 minutes. I want you, using your steps, determine how many grams of hydrogen gas will you need to react with 35 grams of nitrogen. One thing you gotta remember is that nitrogen is 15 times heavier than hydrogen. The ratio might be there, but you're still counting grams, right? So it's not just gonna be an even 1 to 3 situation. The size of hydrogen and the size of nitrogen are gonna greatly affect that value.
So, Mr. Weissman?
I'll tell you it's more than 3. I was telling 1, so more than 3.
Molar mass, are you measuring, it's 2 nitrogen, measured by voice?
Yeah, because my compound is N2, right?
Yeah, so,
So that means there's 2 nitrogen molecules there, right?
yeah, okay.
So it's not gonna be 1401. We'll multiply that number by 2. The actual weight of that compound will be 28.02. Oh. I'm pretty quick today. Sounds like Mr. Michalski running people down the hallways. All right. Does anybody have a value they want to spit out to us? What do we think is the right answer? What do we think is the right answer? Walk around, see if anyone got it. So, ladies and gentlemen, I will warn you that there is a quiz on this Friday. But this unit is going to be over the following next Thursday. And they said we will take a test on this in that following Monday. We've picked up no new skills. What we're going to pick up today is that we should be able to feel comfortable with our skills to pull from different sources to come to our answer. Chemistry has always been building up to this. Everything that we've done from Unit 1 to Unit 7 is building us up to this point. Freshmen are going to freshmen, I guess. I'm surprised he wasn't Naruto running in the hallways. You know who you are if that's who you are. So step 1, my balanced equation. Step 2, I have 35 grams of nitrogen. I need to figure out how many grams of hydrogen I need. If you're not putting this down on your paper, you're severely kicking yourself in the teeth. Identify what you have and then identify what you need. Step 3, I need to convert my grams to moles. Now, excuse me. I look at my periodic table. I see that the weight is typically 14.01 grams per mole of nitrogen. But I have that 2 there. $35 divided by 2 times 14.01, or I could just type it in as 2802. Gives me 1.25 moles hydrogen gas. Step 4. I need the ratio. I have how many moles of nitrogen gas do I use? How many moles is N2? 1, 2, 3, or 4? 1. 1 mole N2. I want hydrogen. How many moles of hydrogen do I use? 1 mole of nitrogen interacts with how many moles of hydrogen to create 2 moles of ammonia? What's the coefficient, ladies and gentlemen, for hydrogen? 3. 3 moles H2. I'm going to multiply my moles by my ratio. 1.25 moles. What's going to be my denominator? Nitrogen or hydrogen? What do I want to get rid of? Do I want to get rid of the nitrogen or the hydrogen? I want to get rid of nitrogen. So that means that hydrogen has to be on top. So it's going to give me 3.75 moles hydrogen gas. Can I stop here or do I need to go further? Yeah, I need to convert that to grams, right? Right now I have moles. So step 5, .75 moles hydrogen gas. If 1 mole hydrogen gas, how much does 1 mole of hydrogen gas weigh? 2.02, because it's 2 times 1.01 grams hydrogen times 2 times 1.01 gives me 7.575 grams. Question. Can my final answer have 4 sig figs? No. How many can I have? 2. So it's going to give me how many grams of hydrogen gas? 7.6 grams hydrogen 2. I have 5 steps I have to complete.
Why would it be 2? Business don't fight. Middle ground.
The reason why it's 2 is remember how many sig figs my question starts off with. Remember, guys, when I'm converting stuff, how many number of sig figs I start with, that's how many I must end with. Now we could just turn this into one long fraction across. But I figure by identifying the 5 main steps, we better our chances of getting the answer right. Because when I learned this, I didn't have one fraction then answer, another fraction answer, another fraction answer. I had 35.2, this, multiplied by this, answer. There was no stop in between. That's how I learned how to do it. I need a balanced equation. I need to identify what I have, what I want. If I have no idea what I have no idea what I want. Step 3, unless I'm given moles, I need to get it into moles. Because, remember, from your molar map, the only way I can jump from one side to the other, not given to my desired, is it has to go through the mole ratio. Therefore, whatever I'm given has to be in moles first. Step 4, then I multiply it by the mole ratio. Step 5, I have my final answer in moles. I have to convert it into what I want. Do I want grams? Do I want liters? Do I want to know how many particles I need? This makes up basically everything that we are going to do for Unit 8. This piece of paper right here. It will make or break your time in Unit 8. For those who are currently wondering, there's around 33 of us that currently have an F for the year. There's a couple in this class. Can you pull it together and walk out of here with a D and get credit for the last 10 months? Absolutely. This unit is a great place that you can. Why? Because you're not learning anything new. We already learned about differential equations. We already knew how to convert moles to grams, grams to moles, liters, particles, yada, yada, yada. This is nothing new. The only thing is I'm doing is I'm taking a bunch of tools I've picked up along the way and I'm putting them together. For homework, you need to make sure you got your planner out for this. Make sure your planner out for this. You're just doing the first page. You're doing 1 through 7. The back, I didn't make copies for this one. I didn't make any copies of the back. It's just additional problems. Questions 1 through 7. Look at the first one. According to the chemical equation, 4 iron plus 3 oxygen 2 yield 2 iron 3 oxide. How many moles of oxygen are needed to react with 4 moles of iron? 3. Straight from the question. Now, 1b, how many formula units of iron 3 oxide will form when 3 molecules of oxygen react? That one requires you to go through your 5 steps. You're going to answers 1 through 7. You're going to bring that to me next class. We're going to review it. When I see you next class, we're going to do even more stoichiometry questions. Why? Because Friday we take a quiz on it. Those who have not given me the first attempt on the test or need to retake their test, you have 2 weeks to get it done. If you're doing it for the first time, I recommend taking the test this week. So it's graded. We can remediate by the end of the week. And if need be, if you need to retake that test, you have time and space to get it done the following week. Even if we split it up over a nest situation. I will tell you, this week is not a good week for nests. Tomorrow, we have 4B. Wednesday, Thursday, our advisory classes. Friday, we apparently have a pep rally during nest period. So that means that you cannot come to me during advisory lessons or during the pep rally. So I guess I'm gonna be downstairs too. The pep rally is Friday. So, if we stay after school, we get the test done this week. The following week, everything will be graded. We can meet that Monday, talk about what you did, what you didn't do, make small corrections, retake the test for the end of the week. Bing, bam, boom, you're done.